Yeah, I mean, you've talked at length there about the making it simple and making it easy. I guess when we're talking about scalability, we are talking about manufacturing at scale. So if we focus specifically on the manufacturing environment, which in itself presents unique security challenges, secure manufacturing facilities are one of the more common ways to offset those threats. So, but what makes a truly secure manufacturing environment, Malcolm?
Yeah, so it's a really good point, Kira, and the effectively the transfer process that we talked about in the middle there. That's really the crux of it, because we actually encrypt everything that's being transferred from the OEM. That design process is effectively wrapping everything up, encrypting it, and locking it to one device in our factories that can decrypt it. That HSM is then able to re-encrypt uniquely per device or create a unique entity, a unique identity. There is absolutely no way during that process that anybody can get access to any of that information, which is obviously the most important part of secure manufacturing. I think it's important to state at this point as well that we're actually dealing with this at chip level as well. So, because obviously there's manufacturing on a PCB level and there's manufacturing on a chip level. We're able to do this at chip level on our high volume programming machines because the IAR HSM is able to interact directly with each chip as we put them on the programming machine. So all of the encryption that gets put onto the device is actually locked down to each device ID that we read. So we put a chip in the programming machine, we read the device ID, we send that securely to the HSM. The HSM then encrypts all the information that it's been instructed to, and then sends it back to our programming machine to provision it. That's all done at extremely high speed and a completely automated process. So at that point, then the output from us is a pre-provisioned microcontroller that we're able to then ship to the contract manufacturer or OEM's manufacturing location with a completely locked down, secure microcontroller.
Yeah, I think one of the important words you said in that was completely automated, because I guess as soon as you have people involved, you're adding risk. So it's important that what people have access to is fully protected, which naturally, I guess, brings us on to the idea of zero-touch provisioning, which would address the human risk factor in manufacturing. So what role does the HSM or hardware security module play in this approach?
Yeah, so effectively, it's down to taking people out of the loop here again. So if humans are involved with anything, then ultimately there's a risk, because people are not. You can't manage a person to the level that you would need to avoid them being attacked by a malicious actor effectively. So it's all about making sure that the staff in the factories are not exposed to any risk. Therefore, it's impossible to bribe them to get hold of a firmware file that could be maliciously attacked, because all the person in the factory can produce is or they could get their hands on is what we call a PPKG file from IAR, which is completely encrypted and can only be read internally by the hardware security module. I think it's important to say as well, Kira, at this stage, that actually our factories, on top of this protection of their hardware security module, that we're ISO 27001 certified as well, which means that our locations in their own right are secure as well.
And it's also worth saying that, we have additional processes in place, like biometric access to our machines, that we take advantage of there as well. So, Shawn, have you any points to add on that, on the HSM or the zero touch provisioning?
Yeah. So the one question that we sometimes get, as Malcolm alluded to, it's encrypted where only whenever you send a production package from the OEM to the manufacturer, it's encrypted in such a way that only the HSM can decrypt it. And this is a FIPS certified HSM. It has the full meshing potting and everything that you need, so that if somebody tries to tamper with the HSM, the box actually erases itself. So your firmware images, your PKI only exist in an encrypted format on flash in the HSM, and only during a production time does it get decrypted into RAM to be able to run and generate the keys and certificates for any device that you would potentially be using. So the question arises, well, what about between the HSM and the chip itself? How do I protect that? Do you guys take care of that? And the answer is yes, we do. So different silicon manufacturers have different ways of approaching that. So for example, ST has their SFI secure firmware installation, which we work with that. Renesas has their TSIP, and everybody kind of has their own way of doing it. But we actually work with each one of those to secure what we like to call the last inch, to make sure that you're not talking to a hacker at the end of the programming head. It's actually a device that is a real legitimate device that comes from the silicon manufacturer. So that's part of the zero touch policy that we talk about. And of course, some people will raise the question, well, okay, if I'm using a legacy microcontroller, can't you just sand off the top of the chip and read the flash? And the answer is absolutely. But that's why there are devices like TrustZone from ARM that provide the hardware tamper resistance in order to be able to further secure the device. So true security is a marriage between hardware and software. But even if you're using a legacy device, we can enable a good level of protection. And we can make it where, in order for somebody to be able to compromise the device, they basically have to have physical access to it. And when you start using the higher end microcontrollers, higher end in terms of the level of security that they provide today, you can even make the physical access kind of something that doesn't really buy you all that much, because then you need to have a really expensive piece of equipment like maybe a focused ion beam in order to read the flash. So again, what you're doing is you're basically ratcheting up what it takes for someone to be able to hack into the device, and you're making it where they're just going to give up, and they're either going to find an easier target or realize that the juice isn't worth the squeeze, as they say in modern vernacular. But yeah, that's really a great thing that Malcolm elucidated, and just wanted to add a little extra bit on how we secure the last inch.
Mm-hmm, absolutely. The HSM sounds impenetrable, and adding all of these layers of protection on top of each other, so that people just avoid you and move on to the next potential target.
Yes.
So looking towards the future of embedded security adoption, how long do you think it will be before embedded security becomes standard practice across the industry?
That's a really interesting question, because I kind of see some people trying to get into security. But again, as I mentioned, they're trying to use the same symmetric key across all devices and thinking, okay, now we're secure. That's a pretty low bar that you just cleared in order to say that, yes, we're implementing some level of security. I think as more regulations come out, as I mentioned, the GDPR in Europe, and you're going to have a special version of the GDPR that deals with medical devices. The FDA has now put cybersecurity regulations in place on medical devices. So it's, I think in Europe, the IoT devices were the tip of the spear for you guys. And then when GDPR came in, that was really the thing that was at the forefront of the battle. In the United States, it seems like medical devices are going to be the tip of the spear. followed fairly closely probably by automotive as we look at 5G technologies and automated driving and how it's depending upon communication with other cars. That authentication and hardware-based HSMs for automotive devices is going to become a much bigger thing. So I see it as being a relatively quick thing because people are getting to the point where they can no longer avoid it. They realize that not only is the regulation either there or imminent, but now we've actually talked to certain customers that are, for example, in the consumer electronics space, that their European vendor told them, we will not sell your product because you don't have any security in it. And they were trying to hide behind well, we don't collect personally identifiable information. And their vendor said, I don't care. We have this thing called GDPR. We're not taking any risk because we're just not going to sell your product. And that's when this particular company, which is a multi-billion-dollar company, by the way, suddenly realized we have a security problem that we need to address. And that's when they really wanted to get in front of it and find these simple, scalable solutions that we talked about. So I think 2025 is really going to be the year where security comes to hit practically everyone. And they may think they're addressing it with a low bar, but they're probably going to realize as the legislation evolves that they need to up their security game, and unique identity and unique asymmetric keys are going to be the standard benchmark that everybody has to hit. So I think this is going to be a really breakthrough year for security in that regard.
Yeah, I agree. When you're talking about medical devices or automotive, where there's a true risk to human life, that really increases the impetus to engage with and implement security for IoT systems. And we can see that, the shift from hackers has gone or is going from IT systems to IoT systems. And, there was recent research from Forescout backed by the IoT M2M Council. And it was indicating that the number of vulnerable IoT devices has increased by 136%. And there is a major shift from hackers going at IT to IoT. And given this shift, to finish up, what are the immediate steps that manufacturers should take to protect their products and most importantly, their end customers? I'll ask that of you first, Malcolm.
Yeah, and just as we're talking there, Kara, I was just starting to think about what we call a secure element, which is a hardware security engine. And when you think about people taking action, actually a lot of people did take action by putting secure elements on their board, but it's actually a scary fact that not a lot of those secure elements are not actually switched on. And that's because the provisioning process for those secure elements is quite complex. Again, it's about putting something unique into a high volume product. It's not a simple thing to do. So what we do, we kind of solve two problems here. First of all, we can get to a very extremely high level of security without that secure element. And secondly, we're able to provision in high volume very unique credentials into each device. So, and then just to think about your direct question there, it's really about taking on board the solutions out there that are helping, that we're putting out there to help customers fix this complicated problem. To go back to the three-step approach, we've got design tools that we enable you at the design stage. We enable you to transfer the file, and then we enable you to provision that unique information. We're now getting, this is now broadening, our scope on this is now broadening, where we're doing it already with several customers. And everybody's experience of this so far has been extremely positive. So I'd really recommend customers to research into what we're doing here at IR and EPS, and really just reach out to us when they need support, because the solution's there to help them. It's not expensive in relation to what can happen if you don't put security in place. and it's the quality of what we're doing is extremely high. So yeah, reach out to us and
that's perfect.
Yeah. And I would just add on to that our embedded trust solution can also target secure elements if you feel that that's what you want to do in order to try to retrofit a manner of security onto an existing hardware design. There are some design challenges with that in terms of making sure that the bus is not able to be sniffed on the PCB. So there are some side channel attacks that can occur with that, but we have experience with that and can help you understand some of the different things that you need to think about as you're doing it. But there's also another aspect of it too. Some people may be looking at, well, I've had this hardware design out there for years and I really need security, but I don't want to completely redo everything that we've done in terms of certifying the firmware that's on the device. We actually have something that is a part of embedded trust called ESEC IP, which is a late stage security that allows you to retrofit an authenticated boot onto a device. Now, ESEC IP is a little bit different from embedded trust in the sense that while it does give you authenticated boot, it doesn't give you the ability to do firmware updates, but it can at least give you that authenticated boot and buys you time as you try to do a more robust security design for your next implementation. So as Malcolm said, the security solutions are not very expensive. I like to say that good security is hard, but if you're using really good tools, the security becomes way simpler and easier. And it's also really good when you have a trusted entity in the security game. So IAR Systems has over 30 different security patents that have been filed around our products and services to help customers be able to tackle these challenges. But from a minimum, if you're trying to roll your own security, you need asymmetric keys on each device to provide unique identity. Those asymmetric keys give you the ability to generate symmetric session keys that you can use for firmware authentication or passing messages back and forth. But those two things basically form the crux of what you're doing, along with hash functionality to be able to do signatures for data or firmware that's being transferred across. And it can be a little bit challenging and a little bit scary, but when you're using the right tools and you have security experts in your corner for a relatively inexpensive price, it can check the security box for you in a way that you can be confident that you have a world leader in your pocket. And combining that with the manufacturing and programming and provisioning capabilities of EBS means that when your C-suite comes and says, what are we doing about the security thing? You can say, we've already checked that box. We already got it taken care of. And they'll probably say, oh, great. On to the next thing,
They'll say, oh, right, thank you.
Yes, exactly.
Okay, really positive way to finish off this podcast, Shawn and Malcolm. Thank you so much for your valuable insights. It's clear that embedded security is no longer optional, but essential for product integrity, brand protection and reputation and regulatory compliance. While the challenges exist that we've spoken about in terms of implementation and cost, relatively small, solutions are available that can simplify the process, that can scale the process and protect devices throughout their life cycle. And the manufacturers who move proactively on security will not only meet their regulatory requirements, but they'll gain a competitive advantage in an increasingly security conscious market. I'd like to thank you both for joining me today on the Critical Lowdown, and we'll speak again soon. Thank you.
Thank you.